Welcome back. We're still in the heart of Nemek in Al Fustat in Cairo. And you know, the National Museum of Egyptian Civilization, dear viewers, employs advanced technology of scientific analysis to investigate and interpret the cultural heritage materials. Therefore, it hosts a number of scientific equipments to valorize cultural heritage and present information about the past civilization. Science and civilization is the topic here in this segment of Nile Cruise, and with us is Dr. Mina Magdi, and he is a senior scientist at the Scientific Labs Department here in Nemek. Very good evening to you, Dr. Magdi, and thank you for having us, and
Yes.
thank you for being with us. So, Dr. Magdi, what is the role of scientific analysis in the archaeological context?
Okay, first of all, it is my pleasure to have the opportunity for such an interview with the Nile TV channel. Scientific analysis plays vital roles in the archaeological field. Actually, archaeology, it is an interdisciplinary approach that involves different stakeholders from different disciplines such as chemistry, physics, geology, microbiology, DNA studies to present information for the conservation strategy. Scientific analysis, it is a stepwise plan. Starts with the main objective or research interest or research problem, or I can say, what do you want to know about the object or the material studied? So we collect the documentation data and visual observation and make analysis. That could be non-invasive without any sampling from the object, or invasive that be non-destructive. The sample is revertible recovery of the samples, or destructive for the samples, according and choose the suitable technique or the method according to the parameters of characterization technique. For example, I want to to investigate the molecular structures, elemental concentrations, surface imaging, separation of components, investigation of the thermal stability of behavior of the components, make data analysis, data interpretations, and the data presentation to conservators to take decisions regarding the preservation issues. So it is one of the aims of the analytic scientific analysis to present data to conservators.
Wonderful. So could you provide us information, Dr. Magdi, about the labs here, the scientific labs here at Nemek? You're a senior scientist at the Science Labs Department. Talk to us about the laboratories that you have here at Nemek.
Have here, yeah. Nemek is a research hub for archaeological studies or archaeometric studies. We have different facilities, huge facilities with high technology. For example, if we receive artifacts at the platform, and the first 8 labs goes to anoxia to isolate the object from any insects or aerobic microorganism in absence of oxygen. We have a huge facility, anoxia, and portable unit. After that, we have bioarchaeological labs that could be bioanthropology to study the human remains, to get information about the age, sex, diet, activities of the ancient men, the environment, interaction of the man and with the environment, modifications of the environment. We have zooarchaeology with non-human animal remains. Also, we have archaeobotany. We have archaeobotany to study the plant and seeds remains, to get information about the food, about the cooking, about the shelter and the building rituals. We have ancient DNA. It is specific labs to study the ancient DNA. For example, the metagenomic analysis to study the functions and the composition of the genes, familial interrelations, and phylogenetics analysis that could be useful in the evolutionary studies. Comparison between the contemporary and the ancient microorganisms. We have a biobank lab for preservation of the unique samples. For example, it is could be animals or plant samples. We have center labs, chemistry and physics labs. We said before that we can study the according characterization parameter.
So what more, Dr. Magdi, do the labs do here at NEMIC, and how important is their role, in providing information about the scientific material that we have before we display the monuments?
We have a certain labs that contains microscope labs. For example, we have a stereo microscope for 3D visualization of the samples, a polarized microscope to analyze the rocks and the minerals, pigment containing samples. We have an inverted microscope for metallurgy to study the metals and the opaque or thick samples. We have fluorescence microscope for biological samples for visualization and localization of the target molecule in the samples. We have molecular labs to investigate the molecular structures. For example, we have FTIR. And we have to study the optical properties or electronic properties. We have UV visible spectroscopy, and it is within the near infrared range. Also, we have diffuse unit to avoid consumption of the samples within the solutions. We have the diffuse unit, and we have also the optic fibers that can be used in the not using the reflected light. We have fluorescence spectroscopy for the native fluorescent. We have a thermal analysis to investigate the chemical and physical properties of the sample as a function of temperature or heat. For example, the TGA, thermal gravimetric analysis, to investigate the thermal stability and the thermal behavior of the samples, and the DSC to make a comparison, investigate the comparison with sample and the reference to investigate the information about the heat flow. For example, there is heat flow into the sample or out of the sample, endothermic, exothermic, melting, crystallization. We have DMA, dynamic mechanical properties, to investigate the mechanical properties, which one is more cross-linking. We have also the elemental labs, for example, atomic absorption spectroscopy that can be reached to part per millions or part per billions, and ICP-MS that to detect the ultra low concentrations, reaching to 10 minus 12, 0.0012, so can detect the very, very low concentration of the samples. To make analysis, just plasma and goes to the ICP-MS. We have chromatography labs for separation of the component of the samples. For example, painting or mummies, I have many components of the samples, wax, resins, oils, to separation and identification. We have ultra performance liquid chromatography, TOF, time of light. It is superior than the normal or ordinary version of HPLC, with a short column called the BH silane bridged hybrid, with high advanced mass spectrometer called time of light TOF mass spectrometer. We have a GCMS headspace for the volatile samples or higher thermal stability, and headspace for the gas space or volatile solvents, so can achieve more informations. We have for dating carbon-14 for only for carbon-based materials, carbonized materials that can to date the sample up to 50,000 years old, to detect the amount of carbon-14 present in samples. comparison with the reference samples using a liquid scintillation count. We have a particle analyzer called SLS, static laser scattering, to detect the average size of the samples from 0.002 micrometer to 2,000 micrometers, either it is dry or wet samples. We have it is a bench top or fixed labs. We have a portable instruments or labs that can be goes to the excavations or the building or temples using the FTIR, Raman spectroscopy for molecular structures, XRF to detect the elements present in the samples. We have X-ray radiography as in the hospitals to determine the internal structure of the object, and if there is abnormalities such as cracks or voids.
Wonderful.
Yeah.
So what, Dr. Magdi, have you found as the most important or unexpected or findings that have been generated from the analysis that you do at the labs? I'm sure that you found something, you know, that you didn't expect, something very important, something very significant. Tell us about through the great analysis that you do.
I will take an example.
Yes, please.
Usual findings, we present the data to conservator to take a decision for the preservation. For example, the conservator will make consolidations, cleaning, protective coating, for example, polymer or gel, or preventive conservations. For example, if you will see just devices to monitor the surrounding environment to control the temperature and the humidity. We can give information to the conservators that can help us in the display galleries. For example, if I have coins, I can study the corrosions and make analysis to detect the concentration of the elements. So this coins dates to the Ottoman or Ptolemaic or Greek periods. So according to the analysis, each period is characteristic with elements. Also, when the visitor or you visit the mummy's room, you will see screens with informations from the analysis. For example, you will see screen with radiological images that illustrate death of the king, either by knife in the neck or there is a foot disease. What is the reasons of degradation of the mummies? Which layers of the painting it can be refers to 16th century? No, it refers to 19th century. It is a value of the analysis of findings in the archaeological.
How accurate are these analyses? How accurate are they?
Accuracy depending on the instrument itself and integration of complementary of the analysis. For example, one of IR molecular structures make authentications with the Raman. So according to accuracy of the instrumentation and accuracy of the operators and the integrations of the overview of many analysis to authenticate and confirm the findings.
Usually, how accurate are they? Like 95%, 98%, 80%, 65%? The degree of reliability on the analysis?
The analysis is reliable 400 for the analysis, but sometimes maybe there is interventions. So I can make analysis for some materials used in the past. But when you make recent restorations, I can make analysis. So it is refers to, for example, Persian blue. Persian blue, it is appeared in the mid of 18th century.
Right.
So according the instrument is very, very reliable and accurate, reliable results, and they make integrations and complementary story or scenario with different techniques. For example, thermals, XRD diffractions, Raman, elemental analysis. Sometimes we use statistical or computational analysis to take overview about the studied object.
Dr. Magdi, how does NEMIC Scientific Labs collaborate with different organizations?
Collaborate. Okay. Usually we collaborate with different organizations, but I would say in the upcoming period, there will be an opening or inauguration of the Center Labs. So we are planning to broaden the collaborations and partnerships with different organizations. For example, broaden the work with foreign missions to investigate the archaeological materials within the framework of preservation of archaeological chemistry. So it is expected, it will be expected to be many collaborations with different organizations, institutes and universities and the missions after inauguration of the Center Labs.
Perfect. Finally, Mr. Magdi, Dr. Magdi, can you tell us about the educational activities that you have here at NEMIC?
We have different activities at the NEMIC. For example, every year we have summer school or winter schools. Within these schools we have theoretical lectures and the practical workshop. Also we have a symposium. We have certain or specific programs, for example, personal internship after approval of the or coordination with administration of the museum. We have also the education center for the kids. It is very amazing center to educate and increase the awareness of the children with information about the ancient civilization. It is free and very amazing. Also, we are planning to make many activities after the inaugurations. For example, we will have the students or the researcher will be able to book a bench lab and make analysis and use our instrument and participate in the research or project.
That's beautiful.
So it's very important.
That's beautiful. Thank you very much. It's been very informative, by the way. Dr. Mina Magdi, the senior scientist here at the Scientific Labs Department at NEMIC. Thank you, sir, very much. It's been a great pleasure. And dear viewers, please stay with us. Nile Cruz will be right back.